Assalamu alaikum. The course which we are going to start is Digital Signal Processing. This is our lecture number 1. My name is Anam Javed and my registration number is 16TE82. Before starting this course, we must know what are the CLOs. CLOs are basically the course learning outcomes, which means that at the end of this course, we are able to describe the following main CLOs. CLO number 1. Explain fundamental concepts such as linearity, convolution, correlation, and LTI. CLO number 2. Analyze the digital signal and system in the time domain and Z domain. CLO number 3. Implementation of FIR and IIR filters using variety of techniques. The books recommended for this course are given below. Book number 1 is The Scientist and Engineer Guide to DSP. Book number 2 is DSP Fundamentals and Applications. Book number 3, DSP using MATLAB for students and researchers. The DSP term is basically divided into the three main words. The first word is digital. So let's discuss digital. Digital is basically finite number of values to represent elements of the physical world. Now what is meant by finite? Finite is basically the portable or something that is within the range. Its example can be taken as, let's suppose I have money in my pocket and you don't have. So it is within the range for me and it is finite for me, whereas it is infinite for you because you don't have it in your range. Now what is it example in the real time? Let's suppose we want to represent an element x in the real world. We will represent it either by using 0 or by using 1. And if our world increases, that we not only have an x, we also have another element named as y. So we can use the combinations such as 0, 0, 0, 1, 1, 1 and 1, 0. Similar case for if the world increases from 2, 3 or etc. The second term that comes is signal. Signal is any physical quantity that vary or changes with respect to the independent variable. What are the examples? Let's look at the example. The first example is the image signal. Image signal vary with space. Image signal vary with space means that if we take a picture of a person or some object at a nearby distance, then it is not going to give good or the very best resolution of the pixels as compared to the one taken at a suitable and within the range signal of the object. The second example is the audio signal. Audio signal vary with pressure. It means that, let's suppose if a person is speaking inside a class, then its sound or its voice will appear clear to the audience that are sitting nearby than to those that are sitting at the end. This means that voice vary with pressure. The more pressure the speaker will apply, the more clear the voice will be to appear to the audience. Now what are the types of signal? Types are, number 1 type is digital. Digital type is also known as the discrete type, and analog is also known as the continuous signal. Now let's look how analog signal look like graphically. This is the graphical representation of an analog signal, and this is the digital representation of, this is the graphical representation of a digital signal. Now look at the analog signal. This analog signal is continuously varying with time as the pointer is moving. This shows that it is continuously varying with time, and at each instant of time it has a new value, a changing value, an infinite range of values we can say. And now look at the digital signal. Digital signal also have a varying set of range, but it is limited, that its set is finite. It is either high or low, that is either 0 or either 1, low or high, low and high. For analog signal, if we want to see its range, if we draw a line here, then here, and then here, it means at each instant of time its value is changing. From this point, let's suppose this is 0 and this is 1. Then in between 0 and 1 there is so many infinite values. and in this case we only have a low value and a high value, that is 0 and 1. Now the next thing is what is meant by processing, as the third basic term of DSP, digital signal processing, is processing. So let's discuss processing. Processing is basically algorithms for manipulation, transformation of one form of signal to another form of signal. Let's consider the example that will explain the processing. This is signal number 1, which contains temperature that is varying with respect to the time that is taken in hours, and signal number 2 also contains temperature, minimum temperature and the maximum temperature. Now what the word processing means? Processing means that it will process the signal number 1 and it will transform the signal number 2. Signal number 1 appear to be complex to the user and signal number 2 appear to be the useful because it contains limited number of values. As it is written, signal number 1 is processed and transformed into the signal number 2, hence it is a technique that involves in decision making process. As the signal, one form of signal, that is signal number 1, is converted into the second form, that is the signal number 2, which basically describes the definition of the word processing. The next thing is definition of the DSP. Now what is collectively meant by the DSP? Mathematics or techniques used to manipulate signal after they have been converted into digital form. Or another definition is DSP is concerned with representation, transformation and processing of signals on digital computers. On digital computer, it means that we can design algos and we can develop logic to solve the problems or to digitally represent the signals. Now the next thing that comes is the importance of DSP in why we study DSP or why it is important. The first thing is to make elements or objects of the world easy, that is, it make analysis easy. As I have previously explained the example of the temperature, the first signal appears to be complex and the second signal was easy to manipulate. So saying that it make our analysis easy. Design algorithms. As I already told that on digital computers we can design or develop logics to solve the problems, to meet our daily basis applications and many more things. Facilitate signal in both domains. Both domains means that it not only consider time domain signal, it also consider frequency domain signal. So DSP plays a very major role in our daily life. Everything we have in our daily life involves digital signal processing. This is all from lecture number 1. Thank you for watching.